Hi folks, we're back again. So we're going to continue on from where we left off. So we're actually on an extension section called 3.4 extension. And this has to do with compound inequalities. And then we're going to also talk about something called absolute value inequalities. So these are things that are a little bit different than what we've been experiencing before. Now we're going to be talking about putting what they call constraints on more than one side of that number. For example, okay, let's talk about this. Maybe I have a rectangle and I take a rectangular piece of paper and I cut out a rectangular center of that piece of paper. Okay? So this goes away, right? I'm saying that I'm going to get rid of that piece of paper in the middle and I'm just going to be left with this oblong, open rectangle piece here. Let's put in some numbers. I've got 3, and 5, and maybe 1, and x. And I want to talk about the pieces. I want to talk about the area that's left after we cut out that rectangle in the middle. And I want to say that this piece has to be, I don't know, at least 10 square inches. Let's just pick a random number. So I want the area of the shaded region to be at least 10 square inches. Well, there's a couple of things in play right now because we have to remember, first of all, how would I find the area of that shaded region? Think about that for a minute. Okay. Well, the idea that this is being cut out means there's going to be some kind of subtraction, right? So it's almost like I have to find the area of this large rectangle and I'm going to subtract off, or cut out is subtracting, right? The area of that small triangle. So I'm going to write that in words. Area of the large rectangle minus the area of the small rectangle. And that has to be at least 10 square inches. At least 10 square inches. So that means at least would mean greater than or equal to 10 square inches. But it can't be bigger than what I started off with, right? I started off with a rectangle that was 15 square inches. So now you're starting to see how it can be bigger than a certain amount, but it has to be less than a certain amount at the same time. That's why it's called compound. So we're dealing with something that's going to put constraints on both the top and the bottom side of what that variable could look like. Let's just start. Let's just take a look at this example some more. The area of the large rectangle is 3 times 5, right? Base times height. Maybe a little reminder here. Area of a rectangle equals base times height. And over here, I have the area of a rectangle being 1 times x. Well, that's kind of nice because 1 times x is just x, right? And that has to be greater than or equal to 10. Well, I can solve this inequality. I'm going to start by subtracting off 3.5 from both sides. Oh, sorry, it's not 3.5. Silly me, that's 15. Minus 15, minus 15. And I end up with negative x, because remember that symbol comes down with it, is greater than or equal to negative 5. Well, I can't have a side that's negative. Oh yeah, I forgot. I have to divide by -1. Ding, 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 ding. -1, dividing by a negative. Remember, divide by a negative switches the inequality. So I'm going to get x is less than or equal to 5. Well, yeah, that makes sense. So as long as x is smaller than 5, or it could be equal to 5, that would be interesting, then the area of what I have here will end up being at least 10 square inches. But my question to you is, if that x were 0, would I still have a rectangle? So if I look at all these x's that are less than or equal to 5 on a number line, so here's 5, 4, 3. That would have been this set of solutions, right? It would be all of these numbers that keep going to the left from 5. But once I get to x equal to 0, now that's no longer a rectangle anymore. And so that's what I'm calling that lower bound. X can't equal 0, and obviously x can't be a negative number because I can't have a negative side. So I need to write another inequality to talk about x. So I'm going to write this, but x can't equal 0 or a negative number because then there won't be a rectangle anymore. Right? The sides need to be bigger than 0. Bigger than 0, right? So those sides, that x, is going to have to also be bigger than 0. So what's my solution for x? Here's my solution. I'm going to say that x has to be less than or equal to 5. That was the first thing that we talked about. But at the same time, so I'm going to say and x also has to be bigger than 0. It can't be equal to 0, so I'm not going to put an equal on there. It can't be 0. Let's see what that would look like if I graphed those solutions. So here's 0. 1, 2, 3, 4, 5. Well, let's talk about that. So it can't be 0 and it can't be less than 0, but it can be bigger. So I'm going to start my line off to the right here. Okay, I'm going to keep going, it can be 5, but it can't be bigger than 5.